Today we'll talk about avalanches. What is an avalanche? Let's say there is a mountain covered with snow. This is its slope. Now if for some reason this snow starts moving rapidly down the slope, it will be called an avalanche. In simple words, the mass movement of snow down the slope is called an avalanche. Sometimes rocks also come down along with the snow. The destructive potential of avalanches is very high. Imagine millions of tons of snow coming down at a speed of 100-200 km per hour. What will happen then? Everything in its path will be destroyed and buried under the snow. It will be so quick that there will be no time to escape or save yourself. How do avalanches occur? Look, there is a mountain, and on top of it, layers of snow slowly accumulate. Think of it as layers of snow stacked on top of each other. Now gravity is always acting on it. This snow has some mass, and gravity pulls it downward. If we break the forces acting on the slope into components, one will be the normal force, which acts perpendicular to the slope and holds the snow in place. The second component will be the shear force, which acts parallel to the slope and pulls the snow downward. At the same time, friction acts in the opposite direction, preventing the snow from sliding. So these forces act on the snow. Until now, the snow has remained stable. It stays stable as long as the shear force is less than or equal to the friction. However, as soon as there is a trigger, such as an earthquake, wind, or the movement of a living being, an additional external force acts, causing the shear force to overcome the friction. When this happens, the layers of snow become unstable and start flowing rapidly downward. Loose snow moves downward and causes an avalanche. If the snow is dense and compacted, it holds well. Such layers are strong. In contrast, layers of loose snow are weak and more likely to trigger avalanches. The slope angle also plays a crucial role. Naturally, the steeper the slope, the greater the risk of an avalanche. An ice mass can start from a single point and spread out as it descends. Alternatively, a large piece of ice may break off and fall suddenly as a single unit. Both are considered avalanches, just that they are different types. The second type, where a massive chunk of ice or rock breaks off and falls at once, is more dangerous. Avalanches cause significant loss of life and damage to infrastructure. They also destroy wildlife habitats and vegetation. Since such a massive amount of snow moves at high speed, its kinetic energy is extremely high. So anything in its path will be crushed or flattened. Some regions known for frequent avalanches include the Himalayas in Asia, the Alps in Europe, the Rocky Mountains in North America, and the Andes Mountains in South America. However, it is not always possible to predict avalanches accurately. Snow conditions can be monitored, and weather forecasts can be checked, which helps identify risks to some extent. With advancements in AI, we'll be able to make more accurate forecasts over time. Still, what remains lacking is our respect for nature. We underestimate its raw power, and then we face the consequences. Climate change is nothing but a result of our disregard for nature. As the earth gets hotter due to global warming, precipitation patterns are also changing. Rising temperatures cause snow to melt, making it wet and thin, which affects the stability of snow layers. Water-saturated snow has increased chances of sliding. Repeated cycles of freezing and thawing weaken snow layers. If triggered, they can collapse, causing avalanches. A study in the Western Himalayas found that avalanche frequency has increased nearly 10 times in the last 75 years. Previously, avalanches were reported roughly once every decade. Now they occur almost annually. Lack of snow is decreasing the number of avalanche events at lower elevations, while increased snowfall in higher and colder regions is raising the number of avalanches at higher elevations. Climate change is also altering the timing and seasonality of avalanches, making them more difficult to predict. Additionally, ongoing climate change is causing glaciers to retreat, destabilizing slopes and increasing the risk of avalanches. As temperatures rise, permafrost will melt, weakening solid compact slopes and further increasing avalanche risks. This poses a serious threat to the survival of mountain communities. We often prioritize the economy over ecology, but when avalanches become a risk, the economy is also impacted. If there is a high avalanche risk, who will come for skiing? If there is a danger of getting buried in snow, who will stay in the resorts? As a result, tourism will decline. This means that by neglecting the environment, we will ultimately suffer significant economic losses as well. Changes in avalanche patterns will also affect water availability, as the melting snow that previously supplied water will be impacted. Climate change is altering the frequency and pattern of avalanches, threatening the safety of living beings, infrastructure, and ecosystems. This is yet another reason why we must take climate change more seriously.